Hello everyone, my name is Krishna Chaudhary. Today I on Lab Assignment 3. My roll number is ID 2K2444, enrollment number D24020045. Now, first question is find root of polynomial equation fx x square minus x plus 1 is equals to 0 by bisection method. Assumption that was now the theory. Bisection method repeatedly divides interval into two equal parts to local root. Now the Python code def fx return x square minus x minus x plus 1. Now the a is equals to 1, b is equals to 2, e is equals to 0.0001, while a b is b minus a greater than e. Uh, c is equals to a plus b by 2. If f c equal to the 0, break it L if FAFSC into less than 0, then B equal to C, ऐसा नहीं है तो फिर A equal to C. Now printed time complexity is over log n space complexity over regular Fonsi method. We have that Python code return x square x minus 1, E is 0001 while true, C is that was the Python code for that. Now the time complexity O(n) space complexity O1. Now geometric interpretation is the x-intercept of second line gives approximated. Now second method. Two initial case are available. Function is replaceable. Say second method approximate root without derivating calculation. Python code. Def fx return x square x minus 1, x0 is equals to x1 is equals to x2. Now e is equals to 0 0 0 1, while fbs x minus 1 is greater than e. Now x1 equal to x2, print root equal to x2, time complexity is O(n), space complexity is O1. Geometric interpretation, the second line between 2 point estimated the root Newton-Raphson method. Now function is replaceable, initial case is near root. Python code was that you can read it by yourself. Now time complexity O(n), space complexity O1, geometric interpretation that was that. Now fixed point iteration method is assumption equation can be written as x versus x iterative equation convergence. Now the theory part that now we move further to Python code. The import my def gx return max dot sqrt x plus 1, x equal to 1 equal to 0.0001, while true x1 is equal to gx if abs x1 minus x smaller than e. Break it x is equals to x1, print root x1, time complexity is O(n), space complexity is O1. Now geometric interpretation. Now we have applied interpolation using data. We have that some data here evaluate F9. Lagrange interpolation हम करेंगे तो data points are distinct. Interpolation polynomial exists. Python was that x and y list xp and variable length of x yp is equals to 0 for I in range and p y, and the last we get the interpolated value of yp. Time complexity is O(n) square and space complexity is O1. Now let's geometric interpretation of polynomial curve passes through all given points. Hermite interpolation. Now we can see their space complexity is O(n) square and time complexity is O(n) square. Both are same. Now let's move further to forward backward difference table. Python code 150, 192, 145, 1362, 5202, and we have an length of y for I in range and table I 0, yi, for z in range 1, and for I in range and z table I z, table I z. Now for I in range time complexity O(n) square, space complexity O(n) square. Geometric interpolation is that now move to the 2.5 meter interpolation. That was Python code x 5 7 11 13 17 158 92 1452. Uh, Now numerical differentiation. 5 150 7 392 11 1452 13 2 3 6 6 7 5 0 0 2. That there are some assumption there are Python code. You can check it for I range n minus 1 directive time complexity O(n), space complexity O(1), geometric interpretation 3.2 method based on finite difference. You can check assumption there. We have that some theory part. We can forward, backward, and central difference. Now we have code x 5 5 7 11 13 17 115 10 92 1452 and space complexity O(1) and time complexity is O(n). Now let's move to the numerical quadrature Newton Cotes formula. A function is continuous, data points are equally spaced, numerical integration is required. Trapezoid rule formula was that. You can check it. Simpson one-third formula. Also, Python code for that we have function which return x into x. We have a0 v4 and for v minus a by n. Sum is also a plus b. For I in range 1 and sum is also result is also h by 2 into sum. Print integral is also result type complexity o n space complexity o1. Geometric area under curve is approximated using trapezoid or parabolic section. General quadrature formula function is integrable function with function are known. Quadrature formula. Now let's move to the system of linear equation. X plus 2y plus 3z is equals to 14, 3x plus 2y plus z is equals to 10, 2x plus 3y 2z plus 4. 14. We have Gauss elimination method. System is linear coefficient matrix non-singular. Now we have a Python code import numpy np is equals to np array. We have b array x is to np linear solve. Time complexity o n cube and space complexity o n square. Geometric representation was that you can see. Now Jacobi iteration matrix is diagonally dominated. Initial guess are available. You can check x time complexity of that is on square space complexity on square geometric interpretation approximate gradually move towards actual solution. Now Gauss Seidel matrix is diagonally dominated. Initial case are available. Now Python code for that x y z are 0 for I range. They we have that. You can compute it in that manner. We get a print xyz value. Now time complexity is O(n) square and space complexity is O(n). Now we have approximation least square approximation. Experimental data points are available. Error are random. The fitting curve is required. Now check Python code for that import numbers np. We have xy two arrays and n variable for pertaining x length sx sy xxy. We have three variable which we can compute it by a is equals to n square x plus y sx into sy divided by n into sx2 minus xx square into xx. We can print best fit line. Now let's check the 6.2 polynomial approximation using orthogonal polynomial. Assumption as function is continuous orthogonal polynomial existed. Now we can check the general formula. That was the general formula for that. Import numpy as np from numpy. Now we can have ordinary differential equation. First one we have Euler method. Function is continuous in initial case. Um, addition is known. Step size is small. We have yn plus 1 yn's plus h x and y. Python code for that def definition which x which add argument xy return x plus y. X is also 0, y is also 1, x is also 1. For I in range 5, y is also 2. We have that. Now the time complexity on space complexity o1. Runge-Kutta matter function differentiable initial condition is known. Theory Runge-Kutta matter improve error accuracy using weighted average slope. Python code for that. We have a function which return x plus y. We have x y is h. We have a loop I which continue to 5 k1 k2 k3 k4 compute by, and we have value of y, which we get x is equal to x plus h. Now print xy, time complexity O and space complexity O1. Now we have geometric interpretation, Picard method also there, you can check it. Now Taylor series method, function is differentiable, high order derivation exists. Taylor Python code was that, you can check the formula, that was Taylor method. Now dy is also x plus y, d2y, a1 plus dy. Now the time which print the y1 value, time complexity O1, space complexity O1. Thank you everyone for checking my video. Uh, just a second. I hope everyone enjoy my video. Please like, share, subscribe my video, and share to your friend. Thank you.